Hello, my name is Manish Patra and my registration number is 242CVZ15. So today I will be explaining the three diagrams of CST with examples. Okay, but before explaining these three diagrams, I want to explain the definition of CST first. So here is the definition of CST. Basically, CST is the temperature above or below which a pair of partially miscible liquids become miscible at a fixed composition is called critical solution temperature. Okay, now we can see CST are basically of two types. Okay, one is UCST and the other is LCST, and I've written here both in the third case. In this case, both UCST and LCST comes. Okay, so under UCST, that is upper critical solution temperature, there are few examples, but phenol plus water example is the most important one, and we will be discussing this example in detail. Under LCST, that is lower critical solution temperature, the example is triethylamine plus water, and we will be discussing this. Rather, I will be discussing this, and then under both nicotine and water, okay, we will also consider this. Okay, so I'm coming directly into UCST, that is upper critical solution temperature, and we will be focusing on the example that is phenol plus water. Okay, now see, uh, just a second. Okay, so phenol in water shows an upper critical temperature of 66.8 degrees Celsius. Okay, that is when we will heat this phenol plus water solution, and which is actually immiscible, or you can say that is partially miscible. After heating it to a certain temperature, and that is 66.8 degree Celsius or above this temperature, we can see the solution becomes completely miscible, and this temperature is known as UCST. And what happens here is, when we are increasing the temperature, we can see the solubility of phenol water is also increasing. So I can also write here, that is solubility of phenol water increases with increase in temperature. So the graph will look like this. The graph will basically look like this. Yeah, so the graph will basically look like this. Okay, and this topmost point will be the UCST point. This is the UCST, upper critical solution temperature, and the value of this will be how much? It will be it will be 66.8 degree Celsius. Yeah, it will be 66.8 degree Celsius. And here what we can see is that we have to take the y-axis as temperature in degree Celsius, and the x-axis as percentage phenol in water, W by W. Here I am also writing this. In x-axis I have taken temperature in degree Celsius, y-axis I have taken percentage phenol in water in W by W. You can see when we will heat this liquid, the solubility of phenol water will increase, and after reaching the temperature of 66.8 degrees Celsius, that is the upper critical solution temperature. After reaching this temperature, if we further heat it, we will see the solution becomes miscible. If the solution becomes miscible, we can see here only single phase is seen, and over here we can see two phases are seen. Over here we can see two phases are seen. So actually what two phases means is here. We have taken phenol in a beaker and water in another beaker, and then we are mixing this. Okay, and then we are mixing this thing. So what we will find here is that we will see two phases. because the solution is not completely miscible, it is a partially miscible solution. We will see two phases in normal condition, that is phenol in water. This is the upper phase, which is present upper, okay, and water in phenol. What phenol in water means, the percentage of water is more here, and water in phenol means the percentage of phenol is more here, okay. So this is what UCST, and this graph is for the UCST one. Now we are coming to LCST, that is lower critical solution temperature. What is this actually? Uh, this is basically in certain pair of liquids like triethylamine plus water. Uh, what we can see in such mixture is that solubility increases in red. I'm showing is that solubility increases with the decrease in temperature, okay. So what we can see here is solubility increases with decrease in temperature. System will show a lower critical solution temperature. Actually, these are some solutions. If we cool the solution, we will reach to a temperature that is the LCST point. And below that temperature, we will see the solution is becoming miscible. Or you can say the solution become completely miscible. Okay, or only one phase is seen. So the here the LCST temperature is 18.5 degrees Celsius. Okay, so that is below 18.5 degrees Celsius, the solution will become miscible. And the diagram will be like this. Okay. It will look like this. Now this is the lowest point. This is the LCST point. Okay, LCST means lower critical solution temperature, and the value of this will be 18.5 degrees Celsius. So below this we can see one phase, and above this we can see two phase. Here also I've taken the y-axis as temperature in degree Celsius, and the x-axis as, this is the x-axis and this is the y-axis. Here I have taken the y-axis as temperature in degree Celsius, and the x-axis as percentage triethylamine in water. Okay, so this is what lower critical solution temperature is. Now we are coming to the third case. Third case is actually, there are some solutions which show both UCST and LCST. That means they show both upper critical solution temperature as well as they show lower critical solution temperature. For example, in few mixtures like nicotine and water, that is what nicotine and water. This solution shows, this solution shows UCST as well as LCST. See, exhibit an upper critical solution temperature of 208 degrees Celsius. This is the UCST temperature, and it also have a LCST temperature that is 60.8 degrees Celsius. Okay, so basically it means this thing. Just a second. Yeah, so basically it means this thing, that is, so above 208 degrees Celsius and below, above 208 degrees Celsius and below 60.8 degrees Celsius, nicotine water becomes miscible in all proportions. Okay, or you can also say that it becomes homogeneous or like that. Okay, so the diagram for this will be like this. See, it is basically not a circle. Uh, I can say it that it is some way like a cyclic thing. Okay, and this is the UCST and this is the LCST point. UCST. Here UCST is how much? 208 degrees Celsius, and LCST is how much? 60.8 degree Celsius. Above this UCST and below this LCST, we can see miscibility. That means we can see completely miscible solution. So we can write here, we can see here one phase. Here also we can see one phase. But between this UCST and LCST, we can see two phases. So that's it. Thank you, ma'am.